in the spirit of what Richard said, that there is a lot of work that is energy related that isn't necessarily associated with the initiative. On the other hand, as he very nicely sort of set up the stage, they are at a stage where they're taking a lot of feedback, and this session hopefully will give you a sense of how much of the rest of the world is also concerned with certain sets of energy issues which are quite different from what's been discussed or what many of you are currently working on. So just this morning, probably most of you woke up and turned on a switch at some point or used electricity in some form or the other and had your breakfast or coffee and got through the day. But just to recognize that there is a large part of the world that does not have access to electricity. In fact, that would be somewhere approximately 20% has no electricity. And then we move on to the bigger problem. That's half the world, 3 billion people, are using a piece of wood. This is not a great camping trip that they're going on and sort of warming themselves in the evening after a hard day's hike. This is just to get that first cup of coffee, okay? So there's about 3 billion, and this would be an energy efficiency, or you can call this energy poverty, but this is an efficiency issue because the way they burn that piece of wood, about 92%, less than 90% of it is not used. And that unused part often becomes particles, and it first stays inside the house, then eventually gets out. And recently, as much as we have public enemy number 1, which is CO2, there is public enemy number 2, which is black carbon or soot, that is sort of now coming up, chasing methane off the list into one of those things that we should be dealing with, this black carbon. And it's particularly problematic in some parts of the world where there are the snow-capped peaks and glaciers, and so this is a concern in the Arctic and certainly a concern in the Himalayas and other parts of the world. And so there is a climate change impact from this inefficient behavior at the household level for half the world, okay? That's one concern. We don't really talk about that in any of the papers today, but it's something that we're working to develop eventually. There's, the fact that this is an inefficient use of wood also means that the local environment is affected. So aside from the air pollution, you have forests that are not sort of generating the wood at the rate that people are extracting them, and this is a contributor to the world deforestation rates. And you'll hear some about that from Charles Welch, who's working with the Lima Center at Duke. And this is the first time we are meeting, so thank you for helping foster that. And of course, the one that people know best is the fact that this black particle is tiny. It gets through your nasal system, goes all the way down, and settles on the lung. And the cook, which is typically sort of the main engine of activity in the household, really suffers. But there's also little kids running around her, and those kids are also deeply impacted by this. So health has always been a concern. They've never really had the resources to tie the health problems to the local environmental problems, to a global climate issue. And one thing that I don't talk about, we won't mention today, but there is short-term effects on coughing and wheezing and then eventually falling very sick, but long-term effects over decades and sort of multi-generational impacts and exposure to the same exposure levels has effects down the line as to how tall you become and how your brain works and how much you end up earning. And tall people make all the money in the world, so we know that that's bad, right? Many things that I said here are unknown, and some of our research sort of touches on that. You'll see examples of that. And then there's still, this is all both on the supply side and the demand side, and that will get clearer when I speak. But today, in my little, beyond the introduction to the other panelists here, I will focus on the health effects and sort of lay the groundwork for looking at these epigenetic penalties. This is joint work with people in the medical center here at Duke and, of course, the Nicholas School of the Environment. Okay? So I didn't know how to spell the word epigenetics a couple of years ago, so this is already something that's tremendous progress for collaboration. Okay? One way to deal with this is Stokes. So there is a technology that presumably is made in a lab somewhere in Boulder, Colorado, okay, or in Corvallis, Oregon. and can help solve the problem, except that the way we are delivering that stove and getting people to use it is not quite right. Okay? That hasn't stopped people like Martha Stewart and Julia Roberts and Hillary Clinton sort of putting this on the agenda. Whenever they're talking about something, it's worth paying attention to, right? So that's what sort of links a lot of the studies that will be discussed today. Okay? Alex will be talking about how we can or cannot sort of see the connections with the health outcomes, and Mark will be talking more about how do we get people's preferences, how do we understand people's preferences and get them to eventually switch their behavior. Okay, so there's a lot of these people out there, 3 billion, and we are trying to understand how different they are and why they care about different things. And then Charles will be talking about how that affects conservation activities in general. But I will talk also about the health effects, but more from a biomedical perspective, not because I know much about that, but because I'm sort of representing this other work. With seed funding, initially from the Global Health Institute and then the Provost's P-First initiative, what we are trying to do is really trying to understand, one, improve technology. This is biogas. This is effectively taking manure that cows produce and sort of burning that. Okay? There's a lot of pipe work involved there, and it's sort of being implemented in a rural developing setting, and so there's all kinds of problems. But what we are trying to investigate is some elements of these triple impacts on emissions, on the local forest, and on health, including epigenetics, as I said. One of our assertions is the way that some of the social scientists have gone and looked at health impacts has been rather crude. Alex will talk about the results he finds, but what people are pushing is that our measures of exposure are incorrect or inappropriate, and so you'll see that we tend to use very fancy gadgets in different places where the gadget itself doesn't work the 24-hour period that it's supposed to document how much exposure a person is involved, is exposed to at any given point in time, okay? And I will talk about some of that and really leave you with some early impressionistic results. And of course, we are also interested in the issue of adoption, but Mark will talk more about that. That is part of a separate project. Right? To pull off this kind of work in another part of the world, it touches on many of the other things that Richard talked about. Engagement and partnerships and education. So there are lots of students involved in this, all this that we've been trying to do, and lots of other partners in country, but also locally at the EPA and CDC, et cetera. So, for example, one thing we've had to do is obviously social scientists, we do surveys. The second thing that we've learned to do in the field in these kinds of settings is sort of walk around and measure people's exposure using monitors that are inside their houses, hanging from top of their cooking stove area, but also hanging around their necks, literally like that thing that's hanging around his neck, yeah? But sort of measuring his personal exposure through the course of the day, just to see, because not everyone sits right around the stove, and so what happens in the remaining hours of the day, okay? And then in terms of the health outcomes, we are looking at how well their lung functions and how well the heart is sort of doing. These are proxy measures. Eventually, we want to get into things that I was not taught in graduate school to measure, things like spit, urine, blood. But that is to show how there is an accumulated exposure over time to this air particle that is penetrating the system and settling on the lungs and sometimes going through, because that has long-term consequences, okay? So very quickly, I will just talk about some of the initial results and then really pass the baton on to the others in the panel. These are raw data. For example, we find that in a house that, this is the exposure monitor up there, that uses what is a dirty stove compared to this biogas technology that involves the manure or a liquefied petroleum gas technology, you see a lot more air pollution concentration, okay? So there's a learning exercise for a lot of the students and us sort of involved in how to do this right. Here's the other way to do it. That's something that looks like a gadget that we've borrowed from RTI, who are our partners in some of this, and we can see over the course of the 24 hours, this is when they're hopefully sleeping, what is their exposure levels and how does that calibrate with the average that you get from around the just around the cooking zone, okay? And to see if the mother is 5 times more exposed than the father, or really it's a local public good. They all share that same environmental concentration over the course of the day, okay? There are others, like in the Nicholas School, who want to see what, there's other ways to characterize this, and so PAHs, which are, I think I got it right, polyaromatic hydrocarbons, which are really awful things. They tend to be higher in these filters that we collect from households that are getting these traditional stoves compared to the cleaner technologies, okay? So the black dots are above the red, and there's all these horrible things that are out there, and they tend to be higher in. So we're just basically proving the point that this is a harmful technology. Of course, I feel that most of the action is in trying to figure out how to get people to switch, and one of our other projects sort of talks about that in a second. Right? Finally, and this is something that Alex will speak to, we actually do not see an effect and difference in lung function between the different kinds of households. And that is because people do all kinds of things between their exposure levels and in other ways sort of compensate that may be neutralizing it. As you see, there's a major asterisk. This is all raw data. This is early work. This is sort of data came in. And as of now, you could not tell that this woman who is exposed to more environmental health exposure is actually sicker, okay? And why is that? You might get some of the answers when Alex talks. Right? So the last slide is one reason that the medical researchers are very interested in this is the long-term effects. So it's not the DNA, as I understand it, it's the RNA. So when you're exposed to things repeatedly in one generation, the next generation, it's not that you become some kind of a zombie and mutate to become another kind of human being, but that the way the gene expresses itself is quite different, and it's often adverse. This is way beyond what I've been taught to think about, but I'm starting to learn about this. But in a more social economic context, there are penalties that you pay which are irreversible, okay? And so there may be reasons to intervene and change these things because there is no way to reverse this kind of exposure within a lifetime, within several lifetimes. And that's what these guys are interested in. And this is a major, major area of work. And it's forced this collaboration in a sense between the medical community in our medical center and us.